Hello everyone, and welcome to week 6 of our class. We are in our final stretch of the class with only 2 plus more weeks to go. And since we are approaching the end of our class, I wanted to make sure that if anyone has any missing assignments, to please work on it and hand it in. I will accept it and review it for you. And please remember that I cover most of these assignments during these video lectures, so please watch them, then submit your missed assignments. And if you did submit something, and it's been a week or more since I've graded it for you, please send me an email reminder. Okay, so for today's class, I will cover 2 new main topics. The first is a topic that will help us to make our code more efficient, and that is the topic of time complexity. Then the second main topic will be about using ChatGPT. So I'll walk you through some steps in using it in different ways to help you be more productive, and also show you how to use it for this week's assignment. But before I touch on these topics, I will also cover last week's extra credit quizzes. Again, these quizzes help to gauge your knowledge of the class topics, plus they are extra credit, so they help to boost your grade as well. Then I will talk about the week 6 material and end the lecture by going through the 2 weekly assignments. So let's get started. Alright, so time complexity is a fundamental concept in computer science that quantifies the efficiency of an algorithm by measuring the amount of time it takes to execute as a function of the input size. Now I will be using the term algorithm quite a lot in this presentation, and to simplify things, algorithm can just mean Python code. And it's important for developers to understand time complexity because it allows them to predict how the performance of an algorithm scales with larger datasets. Now the goal is to analyze our code, then optimize our code so that it runs in the most efficient manner. So as you can imagine, analyzing the efficiency of an algorithm is important in the development of robust and well-performing software. I mean, inefficient algorithms can lead to increased execution times, making applications sluggish and less responsive. So by understanding and considering time complexity, developers can make informed decisions about algorithm selection, ensuring that applications are not only functionally correct, but also optimized for speed and resource utilization. Now this might not really mean much on small applications, but this becomes particularly crucial when working with large apps that use large datasets, in real-time systems, or environments with limited computational resources. So in coding, there's something called Big O notation, which relates to time complexity. And it's called Big O because we use a capital O letter followed by a set of parentheses. The O stands for order, and the notation is often referred to as Big O because it describes the order of magnitude of the function that represents the algorithm's time complexity. So think of Big O notation as like a special label that helps us talk about how fast a computer program works. Think of it like telling a story about superheroes, but instead of using many words, we use a simple label to explain how fast or slow our superhero can be. I'll continue to use the simple example of superheroes to demonstrate the concept of time complexity and the Big O notation. So again, imagine you have different superheroes and you want to know which one is the fastest. Big O notation helps us compare these superheroes by looking at how their speed changes when they have different tasks to do. It's like figuring out if a superhero is super fast all the time or only when they have a specific job to do. So these Big O notations are like secret messages that tell us about the superhero's speed. For example, O function of 1 means our superhero is always super fast, no matter how much work they have. So then we can say that when your algorithm is not dependent on the input size, it is said to have a constant time complexity with order O1, and we call this O function 1. So this means that the runtime will always be the same regardless of the input size. For example, if the superhero's task is to pick up the first toy from the box of toys, then even if the array, or the box of toys, has 1 million toys, the time complexity will be constant. Another Big O notation is O function of n. You get linear time complexity when the running time of an algorithm increases linearly with the size of the input. This means that when a function has an iteration that iterates over an input size of n, it is said to have a time complexity of order O function of n. And using our superhero example, If the box of toys that the superhero has to iterate through keeps growing in the number of toys, so will the time complexity as well. The more toys in the box, the more time the superhero will take to go through them. So we see these in regular loops. Now we also have the big O notation of O function of n squared, which means that superhero gets slower as the amount of work grows, like when they have to save more people. So when you perform nested iterations, meaning having a loop inside another loop, the time complexity is quadratic, which is horrible when it comes to efficiency and productivity. Now a perfect way to explain this would be if you have an array with n items. The outer loop will run n times, and the inner loop will run also n times for each iteration of the outer loop, which will give us a total of n squared iterations. If the array has 10 items, so n is 10, then 10 will iterate 100 times because n squared will be 10 squared, which is 100. Okay, so why does this even matter? Well, think again of your computer like a superhero that can do lots of tasks for you. But some superheroes work faster than others. And if a superhero works really fast, your computer can do things quickly, like playing games or showing pictures. So it's important to know how fast our superhero is to make sure everything happens quickly and you don't have to wait too long for anything to run. So again, imagine you have a lot of toys and you want your superhero to organize them. If your superhero is super fast, they can finish quickly and you can play with your toys sooner. But if the superhero is slow, it might take a long time and you have to wait. Therefore, it's especially important when you have a ton of toys or when you want your superhero to do things in real time, like moving characters in a game or answering questions really quickly. So knowing how fast our superhero works helps us pick the right one for each job and makes sure everything happens as fast as possible on our computer. Alright, now how do we know if our superhero is fast? Well, again, imagine our superhero is like a little helper inside the computer, and they follow a list of instructions to do a task. Now, if we want to know how fast our superhero is, we look at the list of instructions they have to follow. Sometimes our superhero has to do things again and again and again, which are loops. And of course, the more loops, the more work for our superhero. And if our superhero has to talk to other superheroes or do tricky things like solving puzzles, this can also affect how fast they work. So, which big O notation is used and when? Well, if our superhero can finish their task really quickly, no matter how many toys we have, we say it's like magic and we give it a code of O function of 1. But if it takes longer as we get more toys, we might say O function of n. And if it takes even longer, like a lot more times for each new toy, we might say O function of n squared. So understanding this labeling system helps us pick the best superhero for each job so they can finish quickly and we can play with our toys sooner. And so to help our superhero work even faster, we can follow some tips. First, we can avoid making them do the same things over and over too much. If we use special shortcuts or tricks, it's like giving our superhero a super speed boost. We can also use special helpers that already exist in the computer, like built-in functions or importing libraries, instead of doing everything from scratch. So here's an example. Again, let's imagine our superhero is organizing toys. If we use a special box that automatically sorts the toys by color, then our superhero can finish super quickly. But if we use a box where they have to search for each toy one by one, then this will take a lot more time. So by picking the best tools and using some tricks, our superhero becomes even faster and helps us enjoy our toys sooner. Alright, I'll step away from the superhero stuff now and talk about real-world examples. So, in the real world of programming, understanding time complexity becomes especially crucial when faced with complex problems. Let's take the example of a social media platform. When you scroll through your feed, the platform needs to show you posts rather quickly, no matter how many people you follow. If the algorithm used to show these posts has a low time complexity, it means you can enjoy a seamless experience. However, if the code that's behind the social media platform was not written properly or is not optimized, and the time complexity is high, your feed might take longer to load, which leads to a less enjoyable user experience. You might have actually experienced this, when you're scrolling and the screen locks for part of a second until the next item loads on the screen. This can be prevented, or at least improved upon, by creating better and efficient code. And here's another example. Consider a scenario where you're working on a data analysis project with a massive data set. If the algorithm you choose has a high time complexity, it could mean waiting for a long time to see the results. On the other hand, if you pick an algorithm with a lower time complexity, you can get the insights you need much faster. So real-world examples like these demonstrate how the understanding of time complexity directly influences the performance and user experience of applications. Alright, let's talk about ChatGPT. First, let's break down the letters in the acronym GPT. The G stands for generative, the P is for pre-trained, and T is for transformer. So ChatGPT is a chat tool that generates human-like responses based on a pre-trained model that uses the transformer architecture as its backbone. But in layman's terms, it's a very smart chatbot or a human-like virtual assistant. You can have discussions with ChatGPT, you can pose questions, ask it to write you a poem, lyrics to a song, and so much more, like create images and write application code. And the company behind ChatGPT is called OpenAI, and their current website is openai.com, and under the products menu, you can see on the left that ChatGPT comes in different flavors, and you would go to the For Everyone option, and from there, click on Start Now, so you could create your own account and be able to start using ChatGPT. And you can already see down here all the different questions or things you can do, so they do give you suggestions on how you can chat with ChatGPT. Now I already have an account, so I'm going to go to this tab here, and at the top right you can see that I already have an account created and I'm logged in as me. On the left side you have ChatGPT, which basically when you click on it, it's going to open up a brand new chat session, and then down here this is where you enter your prompt. Now up in the top left corner there is a ChatGPT pull down arrow, and here it gives you a couple of options for ChatGPT. There's ChatGPT that's free for everyone, and then there's ChatGPT Plus, which is a monthly subscription, and last I checked it was $20 a month. And if you're curious what is the difference between the two, and if you click on this, it brings up this table with the difference between the free version, which is $0 a month, or the Plus version, which is $20 a month, and then there's also a team version, which is $25 per person per month. Alright, let's close this window now. So here in the prompt I can type anything that I want. I can also attach files to it if you want to have it analyze a picture or review a text document. Again, the options are pretty much limitless. So this is the generic ChatGPT, and if you want something more specific, you can click on Explore GPTs, and from here you can see that there are different topics that are specific for different topics, like writing, productivity, research analysis, education, lifestyle, programming, and so on. Now, some of these, or maybe most of these, require the monthly subscription. So again, explore them. Okay, you can go one by one if you like, and anytime you try to use it, if it says a monthly subscription is required or the Plus version is required, then that's indicative that you have to pay money to use this specific ChatGPT. And I will show you more about ChatGPT in action when we come to the assignments for this week. Okay, before I review the week 6 material, let's go back to week 5, and I wanted to cover both the extra credit quizzes. So let's open up the first one. And just as always, you get 2 attempts. We have 5 questions. There are 0 points because it's extra credit, but every question you get right will be worth 1 point for a total of 5 points. Let's take the quiz. And let's just expand this a bit. There we go. Alright, so we're talking about functions here. How do you declare a function in Python? So to declare a function, we always have to start with the def keyword, followed by the name of the function, followed by parentheses, and then a colon. So this is not the right one. This would be the right answer. def, which is short for definition, followed by a function name. You can call it whatever you like, followed by parentheses. Parentheses can be blank, or they could also include parameters, and then followed by a colon. So this would be the right answer. Question number 2, how do you call a function named myFunction in Python? So a function call is basically the name of the function followed by parentheses. So if the function is called myFunction, then it would be myFunction followed by parentheses. So that's not right, that's not right, that's not right. Question number 3, how do you define a function that takes two parameters, a and b, in Python? Okay, so again, up here we said to define a function, we basically just say def keyword, name of the function, parentheses. Now if you want, and then a colon. Now if you want to add parameters, and inside your parentheses, you basically add the parameters and you separate them with a comma. So down here, it would be def, okay, that's correct. That's not correct, that's not correct. So it's either going to be this one or this one. So def function name, okay, that's correct, my function. And in parentheses, I have a comma b. So that would be the right answer. Question number 4, how do you return a value from a function in Python? So functions can return values, or they don't have to return anything. So to return a value, use the return keyword, followed by whatever value you want to return. Question number 5, how do you define a function that calculates the square of a number in Python? Okay, so they all start with def, yep, so it could be any of this, and then square, and square. Okay, so they all have a function called square, and then they take one parameter called number inside the parentheses, that's correct, and then followed by colon. So up until here they're all correct. And then we're going to return something. So we want to return the square of a number. So the square operator in Python is basically the number followed by two asterisk signs followed by 2. So number is going to be squared, meaning that number uses star star 2. And that's the square operator in Python. So this would be the right answer. Now let's go back to the second extra credit quiz from last week. Again, 2 attempts, 5 questions, 0 points. Let's take the quiz. And let's maximize the screen a bit. Alright, how do you declare a lambda function named square in Python? So we learned last week that lambda functions basically use the lambda keyword followed by some sort of a parameter, which could be functional, and then followed by some sort of an expression. And it's an anonymous function, so it doesn't have a name by default. Now to give it a name, we basically assign it a variable name. So this is not going to work, this is not going to work, this might work, this might work. Okay, so we want to declare a lambda function and name it square. Okay, so lambda followed by x, okay, that's correct so far, and then colon, yep, that's needed, x star star 2. So we learned that x star star 2 will square something. Now the difference between this answer and this answer is mainly the colon here. Now the x here is optional, but the colon is not optional. The colon is must. So the format is lambda optional variable colon expression. So that's why this one's not correct. Now all this is anonymous. We don't know what it's called, but because we assign it a variable name, call it square, just like it's saying up here, then this would be the right answer. Okay, so lambda by itself is an anonymous function, doesn't have a name. If you want to give it a name, so you can call it like a function call, then you have to assign it some sort of variable name. So this would be the right answer. Question number 2, what is a recursive function in Python? Alright, it's a function that includes a loop. It can include a loop, but that's not really the definition for it. A function that calls itself during its execution. Yes, that's exactly what a recursive function is. The function calls itself inside the indented code so that it loops again over and over again. So this would be the right answer. Here it says a function that modifies another function. No, that could be a decorator. And here it says a function that can be declared anonymously. Well, that's a lambda function that we talked about in question number 1. Question number 3, which of the following best describes a decorator in Python? So it's a tool for adding functionality to a function without changing its source code. Yes, this sounds like the right definition. A tool for modifying the syntax of a function. No, because a decorator changes the behavior, but not the actual syntax of the function. A function that accepts other functions as arguments. No, we would call that higher order functions. A function that calls itself. No, that would be the recursive function. So the right answer would be a tool for adding functionality to a function without changing its source code. Question number 4, how do you apply a decorator to a function in Python? So we saw this last week also, that the @ sign is used. So it says here, by prefixing the decorator function name with an @ symbol before the declaration of the function to be decorated. So this would be the right one. Question number 5, what is the result of the following Python code? So we have a variable called multiple, and it's equal to lambda x comma y colon x times y. So lambda here is a anonymous function that has two parameters, x and y. And what do we do with these x and y's? Well, we take x and we multiply by y. Whatever gets returned is going to be saved in this multiple function call. So since this is a lambda and lambda is an anonymous function, we're going to give it a name of multiply. So now we can say multiply with parentheses, which is a function call, pass it the expected parameters, which we have two positional parameters, x and y. So x is 5, and the 4 is going to be y. So what are we going to do with 5 and 4? Well, according to the lambda function, we're going to multiply them together. So when we multiply 5 by 4, we get 20. So that's what we return back as the result, or the return value of the multiply lambda function. So the answer would be 20. Again, I always stress or emphasize the fact that I do want you to take these extra credit quizzes, because number one, they help to gauge your skill and your knowledge of the material that we're learning, and plus it also can give you a boost to your grade. So please take advantage of that. Okay, moving down now to week number 6. Again, the usual 3 sections. Overview, please read this link. Then under assignments, we have a few of them. The usual attendance check, it's a school requirement. Please make sure that you take care of it. And then we have one assignment and another assignment, and then the 2 quizzes. And of course, we have resources, so please go through them. And there is our Q&A forum, which you can post your questions. This can be something generic about the class or about an assignment, but just make sure that this is a public forum, so anything you want to post will be read by the entire class. If your question is something of a personal nature, then please email me in the Canvas inbox. Okay, let's look at our first assignment, which is fixing a recipe using ChatGPT. So I'll right-click on this, open it up in a new tab. So for this assignment, it says, your passion for cooking has flourished, leading you to create your own restaurant. Utilizing your newly acquired Python skills, you were able to create a program that carefully organized your recipes. However, there was a hacking incident and your program was compromised, resulting in scrambled code and deleted functions. So for this assignment, you must debug and fix the code. You need to work with ChatGPT to debug and recreate the functions that form the core of your recipe program. This involves refining the Python code and documenting your steps with comments for clarity in the future. ChatGPT can provide insights, identify potential obstacles, not immediately apparent, and offer assistance in creating efficient code. The impacted Python code can be located in the file titled recipe.py, and you can get an idea of how the code is supposed to run by referring to resource number 1. Okay, so we are provided with a recipe file, and if you click on it, download it here. So this is our code, and to look at it, we basically have a recipe name, the ingredients of the recipe, and the steps to follow the recipe. Then we have a second recipe with its ingredient and steps, and then we have a third recipe with ingredients and steps. And then down here we have some print statements and some loops. But what you notice here is that we have repetitive code. We do this for recipe 1, then we do the same exact thing for recipe 2, we do the same exact thing for recipe 3. Okay, so it's a lot of repetitive work, and in programming this is a big no-no. So we want to see what is wrong with this code and how we could optimize it to make it efficient and better. And so we're gonna utilize ChatGPT to tell us what's wrong with this. So back to our ChatGPT interface, down in the prompt, I'm basically gonna say what is wrong with this code, colon, and then I'm gonna do shift return, then go back to my code. I'm gonna select all of it and then copy it, and then go back to ChatGPT and paste it. Okay, so all I did was, in my prompt, I just said what is wrong with this code and pasted the entire code that was in the assignment file. Then send it, and let's wait to see what we get back. Okay, let's take a look at the very beginning. Okay, so the code you provided works correctly for printing the recipes along with their ingredients and steps. However, there are a few improvements and error handling suggestions that can make the code more robust and readable. Okay, so to avoid repetition, you can define a function to print recipes to avoid code repetition. That's great. Code structure. Group related data and functions together, possibly by defining a class for recipes. And then error handling, ensure that all lists, ingredients and steps are correctly formatted and indexed. And then it also takes the extra step of giving us the actual code. Now this code is a little bit more advanced than what we've learned so far because it includes a class, and we haven't learned about classes yet. So what I can do here now in the prompt, again, ChatGPT is like a virtual assistant. You keep talking back and forth. So I'm going to say rewrite this code but without using classes, just functions. Okay, so now it modified the code, no classes, just a definition, and then how to call this function so that it prints out the recipes correctly. Now you can always test the code. You just have to click on the copy code here. Let's go back to idle, open up a new file, save the copied pasted code, and I'm going to F5 to run it. Of course I have to save it first. Week 6 test code, hit enter, and there we go. It ran without any errors, okay, which is a good sign. But if you go back to our code, one thing I've noticed is that it's not documented or it's not commented. Okay, so part of best programming practice is to make this code commented. So if I go back to ChatGPT, again, if you want to be lazy, you can say, great, now please add comments to the code. There we go. So if you look up here, we have a comment here, we have a comment here, we have a comment here, and we have a not a typical comment, but because it's a multi-line comment, then it separated it on multiple lines and it wrapped it around those 3 string literals. You can do that in Python. If you just want to comment one line, then you can simply do a £. But if you want to comment multiple lines at once, then you could surround it by either 3 double quotes or 3 single quotes. So again, ChatGPT can do a lot of work for us. But again, there is a right way to use ChatGPT and there is a wrong way to use ChatGPT. So ChatGPT is a great tool to help us be more productive, to help us be more efficient. But again, it should not do the work for you that you don't know how to do. So for example, you're learning how to program Python. I can technically say something like, write me a Python code that takes a list and loops through it. Okay, there you go. The code in a matter of seconds is printed out for us. It's going to be working if we test it. But the problem here is that if you don't know how to write Python and you depend on ChatGPT or AI in general, then you are shortchanging your knowledge or shortchanging your education because you're not learning the material yourself. However, when I, who have been programming for over 20 years, use ChatGPT to help me write code, it's just going to help me to be more efficient. I know how to write code. It's just instead of me spending 2-3 hours to write the code, I will at least give it the prompt. I will write up the prompt in ChatGPT, tell it to please write a code that does this, 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 and this, and it will do it for me. I'm not shortchanging myself because I know how to do this already, but I just don't want to spend the 2 hours to do it. Okay, so that is how you should use ChatGPT, at least in programming classes. Okay, so the assignment is asking us to do these steps. Again, write the function, reduces redundancy. So we did that through ChatGPT. Understand how the code should work. As you navigate through the file, use ChatGPT as your assistant to aid in debugging, interpreting code, writing comments. Yeah, we did that. And once you have created a function for printing, add at least 5 lines of relevant code to the code. Yep, ChatGPT did that for us already. Test your code, make sure it runs fine, and then upload your updated recipe file and ChatGPT conversation. Okay, so the recipe.py, that's going to be the actual file, and any prompt that you used, again, prompt being this is a prompt. Just please copy it into a Word document and paste it, and then submit that Word document so I could know what was the conversation that you had between you and ChatGPT. Okay, so that is the first assignment for this week. The second assignment for this week is optimizing the algorithm. Again, this has to do with time complexity, which we covered a few minutes ago. Again, read all this, and we are provided with a file. Okay, you can download it here. And when you open up the file, this is the code that they provide us. So basically, we have a function called hasDuplicates that takes one parameter called input list. And in the comments, we have function to check if a list has duplicates. Unoptimized version with time complexity O function of n squared. So we learned that O function of n squared is basically going to make our code not very efficient and unoptimized. And the code basically is a for loop inside a for loop. So what exactly are we looping through? Well, we're looping through a list called numbers, and the list here, as you can see, has a lot of numbers. Some of them are going to be duplicated. For example, 15 is duplicated, 1 is duplicated. So this code, basically the way it's written, is that we're going to take the first item in our list, then we're going to compare it to every item in the list. Then we're going to loop to the second item and check this against all the items in this list, and go to the third item and then check it through all the items in the list. So that's the 4 nested loops. We take this, so I is going to be this, and every time we take it, then we loop through against all the other items in the list. And once we do that, if there are any duplicates, meaning that the iteration item is equal to any of these values, then we're going to return true. But if there is no equal, then we're going to return false. Okay, so if you run this, the list has duplicates, true. All right, and if we want to test that it's false, let's make this 1 1, and let's make this this. We get false. Okay, let's undo our changes. So basically, I want to rewrite this function in a way that doesn't have nested loops, because nested loops would give me a time complexity of O function of n squared, which is not very optimal, not very efficient. So in this Python code, I basically took this function, just like the assignment gave it to us, then I rewrote it in another function, and I called it has underscore duplicates underscore optimized. Takes the same parameter, and then this function is to check if a list has duplicates, just like before, but it's been optimized with a time complexity of O function of n. So instead of O function of n squared, it's just O function of n. And what I'm doing is I'm going to be using a set instead of a list, because sets don't have duplicates. And I'm going to iterate. I'm going to use one for loop instead of nested for loops. And I'm going to check if an item is in the input list, and if the element is in scene, which is my set that I've created up here, then it's going to return true. Okay, but if not, then it's going to take the element in my iteration variable, and it's going to add it to my set. Otherwise, we're going to return false. So basically, instead of doing nested loops, I'm going to be using a set, and I'm going to be using one for loop. Now the assignment also says something else. So after we do all these steps 1, 2, 3, and 4, which I've discussed already, step number 5 says finally compare the run times of the old and new versions of the function. And you can use Python's time module to measure how long each function takes to run the same input. So back to my code, when I scroll a bit down, you can see that I've added some more information. So starting from here, I'm importing a module called time. Now time is not something that you have to install. It's part of the Python standard library, but you do have to import it so you can actually use it. And once it's imported, then I can use the time method of the time library, and that's basically going to return the current time. So I'm going to set that equal to a variable called start time. Then I'm going to call the has duplicates optimized function and pass it the numbers argument, which is this numbers list, which basically is going to run this function here with this parameter. Then once it runs it, I'm going to call time.time again, which is going to be the current time, and then assign it a new variable called end time. So I'm going to get the timestamp here, run my code, then get a timestamp here. And then I'm going to print a statement that says optimize function took a certain number of seconds, which is the end time minus the start time, which basically I'm saying, okay, I started here, I ended here, so get the difference between these two times, and it's going to tell me how many seconds it took for this function to run. Then I'm going to also do the same exact thing for the original function. I'm going to call the has duplicates, which is the very original function, which is not optimized. And before I run it, I'm also going to take a timestamp before I run it. Then I'm going to run it. Then I'm going to take a closing timestamp, and then I'm going to print out the difference in time end minus start to give me the number of seconds. Okay, so that's basically what the optimized code is going to do. I took the duplicate function, rewrote it in a way that doesn't do time complexity O function of n squared, because it's using two for loops, nested loops. Instead, I'm going to use one for loop, and I'm going to use a set for my data. So when I run this code now, F5, so both found duplicates, which is good. And for the optimized function, it took 0.001615 seconds to run, while the unoptimized code took 0.001697. So the optimized code is slightly faster, and we can technically say they're almost the same, but again, we don't feel the difference with small files or small code or small applications. But if you can imagine, you know, large applications with huge data sets or a lot of things or a lot of tasks to run, then this small difference would be compounded, and you will realize the big difference once the application is big and you compare unoptimized code versus optimized code. So back to the assignment requirements. Once you do all that, upload the updated app.py file into Canvas. So this is what I wanted to cover for this video lecture. I hope it was helpful. Please let me know if you have any questions, and I will see you guys in class. Take care for now, and thank you for watching.